Good afternoon, everyone. In this lecture series, we are going to discuss about the Thevenin's theorem. In the previous video, we have discussed about the superposition theorem and the Norton's theorem. Now we are going to see the definition of the Thevenin's theorem. Suppose the resistors or voltage source, whatever it may be connected. Suppose if the network containing the voltage sources or the current sources that can be replaced by an equivalent circuit that should be consist of an voltage source in series with an equivalent resistance. So this is the statement of the Thevenin's theorem. Suppose VTH is referred to be the Thevenin's voltage and RTH is the Thevenin's resistance. The RL, that is load resistance, is placed across the voltage, that is VTH. We are going to find out the IL, that is VTH divided by RTH plus RL. We are having some set of procedures in order to obtain the Thevenin's theorem. One Thevenin voltage, that is VTH, Thevenin resistance RTH. The voltage source VTH should be in resistance with the resistance RTH that is connected to the load RL. The first one will be the original circuit. We are going to remove the load resistance. The second one is the VTH, that is step 2. In that we are going to find out the VTH. In step 3, we are going to find out the RTH. And finally, we are going to draw the Thevenin's equivalent circuit as we have found out the values. Step 1, we are removing the load resistance and we are going to disconnect the load resistance from the circuit. In step 2, we are going to find out the Thevenin voltage. So how we are going to find out the Thevenin's voltage means we have to calculate the open circuit voltage across the load terminals. That is VTH should equal to VOC. The next one, we have to deactivate all the independent sources. The voltage source should be short circuit and the current source should be as the open circuit. Next, we have to find out the equivalent resistance from the terminals. So, how we are going to find out the equivalent terminals means VTH should be series with RTH. Using the Ohm's law, that is V is equal to IR, IL is equal to VTH divided by RTH plus RL. This is Thevenin's resistance and load resistance. This is the solved example for the Thevenin's. Find the current through the load resistance RL using Thevenin's theorem. This is the original circuit. From the original circuit, I have taken the voltage source Vs is equal to 12 volt, R1 is equal to 4 ohm, R2 is equal to 6 ohm, and the load resistance RL is equal to 3 ohm. Next, we have to remove the load resistance and we have to disconnect the RL. In step 2, we have to find out VTH. In step 3, the next step, we are going to find out the Thevenin's voltage. The open circuit across or AB is VTH. Since the resistors are in series, that is V into R2 divided by R1 plus R2, that is VTH. Here we have calculated as 7.2. Since we have calculated 7.2 and just we are substituting the source voltage as 12, already we know that the resistance R2 is 6 ohms and resistance R1 is equal to 4 ohms. Just we are substituting in the formula, we are getting VTH is equal to 12 into 0.6. So VTH is equal to 7.2 volt. Step 3, we are going to find out the Thevenin's resistance. We are going to deactivate the voltage source. Suppose if we want to replace the voltage source with the short circuit, that is RTH is equal to, that is R1 into R2 divided by R1 plus R2. The value of R1 and R2, that is R1 is equal to 4 ohms and R2 is equal to 6 ohms. That is R1 4 into 6, that is R2 is equal to 6 divided by, we have to add R1 plus R2 which is equal to 10. So we will get the Thevenin's will be 2.54 ohms. So this is the final step of the Thevenin's. The first one, in original circuit, we have to find out across the load resistance. And the case 2, we have to remove the load resistance. And in case 3, we have to find out the Thevenin's voltage. And in case 4, we have to find out the Thevenin equivalent circuit. So we have to find out the current across the load resistance. It will be 1.33 amps. So this is the mind map of the Thevenin's theorem. The Thevenin's theorem, we are going to see what are all the key components and what are all the operational steps, and we have solved an example. With open circuit voltage, how we are going to find out the VTH. In equivalent resistance, we are finding the value of RTH, and the load resistance RL across we are finding. Suppose if we are having the voltage source as 12 volt, R1 is equal to 4 and R2 6, we are going to calculate the RTH, VTH and the total current. So the total current of this problem will be 1.33 amps. Thank you.